Hello everyone, welcome to Unit 5, Bonding. So bonding, there are three types of bonds: ionic, covalent, and metallic. In an ionic bond, the atoms will not share electrons. One atom will give away an electron to the other. In this one, the sodium atom has given away its electron to this chlorine atom, which we'll talk more about later. In a covalent bond, electrons are shared. The orbitals are shared, so two electrons each are shared, such as in this H2O. In a metallic bond, all the electrons just float around with all of the nuclei of each atom. So it's like a sea of electrons. Everything is attracted to each other. So ionic and covalent are the most important. Ionic, you see, an atom gives away an electron to the other, which creates an ionic molecule. One atom becomes positive and the other becomes negative. The one that gives away the electron becomes positive because electrons are negative, and the one that gains an electron becomes negative. In a covalent bond, you just share the electrons. You see the atoms combine like this, and this electron goes here, this electron goes there. Each atom, you see in both these situations, each is trying to get 8 electrons in this shell. So you see covalent, this one has 7, this one has 7. Each of them wants 8, so they will share this pair. In the ionic one, this one needs 8. This one can afford to get rid of its 1. And yep, this one gets 8 in the end. So let's talk ionic bonding. So it happens between metals and non-metals. The metal is a cation that will lose the electron. The non-metal is an anion that will gain it. Hydrogen is the only non-metal that is going to be a cation. Elements want to maintain 8 electrons in their shell. This is what we talked about earlier. It's called the octet rule. They will attempt to gain or lose some to make that happen, creating charges. For example, sodium has 1 valence electron, and it's easier to lose 1 valence electron than to gain 7 more. So it's just going to lose that 1 valence electron and gain a positive charge. Chlorine has 7 valence electron, and the most obvious thing to do is just to gain 1. So it is going to get a negative charge. And when you put these two together, the positive and negative cancel out, so it's about 1. And just NaCl, which is table salt. Now for these two, calcium and phosphorus. Calcium has 2 valence electrons, it's going to lose those 2. Phosphorus has 5 valence electrons, it's going to gain 3. So calcium will be the cation with the positive 2 charge. Phosphorus will have a negative 3 charge. However, you can't combine these because their charges won't cancel out. So we need to find the least common multiple of these two charges, and can't find a way to cancel them out. So the least common multiple of 2 and 3 is 6, which means we need to get this to a total charge of positive 6, and this to a total charge of negative 6. So we need 3 of these calciums and 2 of these phosphoruses. So the final formula will be Ca3P2. Now for Lewis diagrams, it's very simple. Just put the 2 elements and then draw their valence electrons around each other. Then, when you combine them, take this element's electron and put it on the other ones. So that the negatively charged one, the anion, will have 8 dots surrounding it. Positive charged one will have none. Just put brackets around and then add a charge of +1 and then -1. Now for covalent bonding. Covalent bonding is a little bit more complicated, but it's easy nevertheless. So atoms are going to share their electrons. So let's do simple H2O. So oxygen and 2 hydrogens. This oxygen has 6 valence electrons. Each hydrogen has 1 valence electron. Now, oxygen needs 2 to fill up its shell, and hydrogen needs 1 to fill up its shell. Remember, hydrogen needs 2 to hydrogen only needs 2 electrons. Every other element needs 8. So hydrogen will need to gain 1 to fill up, and oxygen will need to get 6 to fill up. The most obvious solution is for these two hydrogens to put this electron into this position and this electron into this position, and the oxygen share this electron with this one and this electron with this one, which means these two electrons will be shared between oxygen and hydrogen, which forms a single bond where two are shared. So that'll be one dashed line, and these two electrons will be shared between this hydrogen and this oxygen, but it's also going to be a single bond, and it will form one line here. So this is the final form of the covalent bond of H2O, where the lone pairs are not shared with the hydrogens, just from the oxygen here. And fun fact, this will form a bent molecule shape because of the lone pairs in the center oxygen. Now let's see about polyatomic covalent bonding. This polyatomic is like this, NH4 positive. Talk about this positive now. So I have arranged the nitrogen and 4 hydrogens around it and all their electrons. This hydrogen is going to share with this nitrogen, this hydrogen is going to share with this hydrogen electron, and this one is going to share with this one. We have a problem here. There's 2 electrons on this side and 1 electron here, but if I add this electron to this nitrogen, then nitrogen is going to have 9, and that can't happen. We need to only have 8. So we need to remove 1 extra electron so this hydrogen electron can fit in. And then 2 electrons will be shared here, 2 electrons will be shared here, 2 electrons will be shared here, 2 electrons will be shared here. There'll be 1 electron that has been removed, which creates a positive charge. Now let's talk about the shapes I was talking about earlier. So lone pairs are just the electrons, like you see here, that are not paired with anything. So if there are no lone pairs in the center, and it's just like this, 3 in a line, it's going to be linear. If it's like this, it's going to be triangle planar. However, if it's like this, where there are lone pairs here, it's going to be a bent. It's similar going to be bent if there's lone pairs here, and then, yeah. So these 2 are bent. And then tetrahedrals when there's 4 surrounding, and triangle pyramidal is when there's just 1 here, 1 set of lone pairs here. And yeah, you only need to know like this one, this one, this one, and this one, this one, and this one. That's probably just some of what's here on the quiz. That's all we learned about. Yeah, make sure you memorize this chart. I'll just pause the video a little bit here. Okay, now let's summarize. Ionic bonds are transferring electrons, covalent bonds are sharing electrons, and metallic bond is just a sea of electrons. So, ionic bonds, they form materials with low conductivity, they're not malleable, have a high melting point, non-ductile, a higher boiling point. Covalent bonds have very low conductivity, non-malleable, lower melting point, non-ductile, higher boiling point. So as you can see, ionic bonds have higher melting and boiling points, covalent bonds have lower melting and boiling points, but both of them are not malleable and not ductile. Metallic bonds, being metals, are malleable and ductile, and they have high melting and boiling points. Now finally, let's talk polarity. Polarity is created when electronegativity difference between 2 atoms is greater than 0.4. We learned about electronegativity in the last unit. You see the electronegativity increases across the periodic table in these 2 ways. Electronegativity is basically the energy. It's basically just the attraction between the nucleus and electrons. So an atom with higher electronegativity is going to attract electrons more. So when there's 2 atoms and one of them has a significantly higher electronegativity than the others, and the electronegativity between these 2 is greater than 0.4, the electrons in covalent bond will be pulled towards the electron with the atom with the higher electronegativity. So this side will get a negative charge since more electrons are here. This will get a positive charge since less electrons are here. This creates a polarized, like a magnet. One pole is positive, one pole is negative. The shared pairs of electrons are pulled towards a higher, right here. And as you can see, because of this chart, with electronegativity increasing across and increasing up, the top right, elements in the top right have higher electronegativities. Let's summarize this into intra and intermolecular forces. Intra is between atoms. That's ionic, covalent, and metallic. That's what we talked about all the way up here. All this is intramolecular, which means that it is between atoms themselves, while intermolecular is between molecules created by those atoms. So that is LDF, dipole, dipole, H bonds. LDF, London dispersion forces, is when the nonpolar molecules, which means that the electronegative difference is not greater than 0.4, just attract each other because the electrons in those molecules are just shifting around and creating some sort of like positive area and negative area. Just very temporary only. It's very weak. Dipole, dipole is between polar molecules when this side, the negative side, attracts the positive side of another polar molecule, and vice versa. Hydrogen bonds are basically dipole-dipole, but with between hydrogen and like O, N, or F, or any other like high electronegativity. It's very, very strong. It's very stronger than this one. And the strengths of these, the stronger intermolecular forces, not intra. Intermolecular forces mean that higher melting boiling points, lower volatility, and high viscosity, which means these are this. These have higher melting points, higher boiling points. These have lower volatility and higher viscosity, which means they're more thicker and they evaporate less easily. And polar molecules will dissolve polar molecules only, and nonpolar molecules will dissolve nonpolar molecules only. That's all you need to know. Well, there might be a bit more. If you ask me for help, I will surely give it. Thank you for watching.